Okay, children, let us continue that measurement of distance of object from the mirror, distance of image from the mirror. In this measurement, some sign conventions must be given because for this case of object, the image is formed in front of mirror. If the same object is placed between P and F, between pole and focus, then the image formed at the back side. In that case, the image is measured from the mirror on the other side. For this measurement, the sign convention must be given because the direction of measurement is changing. There are some rules for the sign convention. Sign conventions used. First one is all the distances, distance of object, distance of image, distance of this focus point, this distance of the center of curvature, all the distances must be measured from the pole of the mirror. That means the pole should be taken as origin. From the pole it should be originated and can move towards the image, move towards the object, move towards focus, move towards center of curvature. So here this measurement is taking place from the pole. Suppose we are using the scale to measure the distance of objects. In that measurement, the measurement should be started from the pole and it is measured in this direction. Suppose this is the scale and the zero of the scale must be placed at the mirror. From 0 we are counting 0, 1, 2, 3, 4, 5 like this. So our measurement is moving in this direction. We are measuring the distance of object in this direction, that is from right to left. Then while we measure the distance of image, it is also measured from right to left. It is measured from right to left. Here this is the distance of object. The distance of object from mirror is given a symbol. That is always it is given a symbol U. U represents the distance of object from the mirror. Otherwise we can say it is the object distance. Then distance of image from the mirror, this is the image distance, that is V. So U object distance, V image distance. It is the symbol given throughout physics. If you use this symbol, it is understood. U is the object distance, V is the image distance. But you can say that I don't like these symbols, I am going to give another kind of symbol. In that case, that symbol meaning must be mentioned below that. If you are using these symbols, there is no need of mentioning what is U, what is V, because it is used in physics. That's why we take object distance U, image distance V. In this measurement, in this image formation, we must know the light rays are coming from somewhere, that is from the object towards the mirror, reflected and to form the image. So from the object the light rays are traveling towards the mirror, that light rays are traveling from left to right. Here the second convention, first convention it was all the distances are to be originated from the pole of mirror. Second sign convention is if a distance is measured opposite to the direction of light ray, it is negative, along the direction of light ray, it is positive. Here see, the light rays are traveling from left to right. Object distance is measured from right to left. Image distance is also measured from right to left. If for any case an image is formed at the back of mirror, virtual image is formed. If the distance of this image is to be measured, in this measurement, our measurement is moving from left to right. Here we use the symbol, that is V, image distance. This measurement of this image distance, are in opposite direction. This measurement is taking place in the opposite of direction of light ray. This is taken place along the direction of light ray. If any distance is measured opposite to the direction of light ray, it is negative. Along the direction of light ray, it is positive. So in this case, U is negative, this is negative, this is positive. So that is the second convention. Coming to third convention, sign convention. Here you see that this is the object. It has some size. The image, it is also having some size. This image, there is some other size. All the objects and images are formed, are having some dimension, some size. And in this, we are considering that all objects, all images are linear. Linear means they are only having one measurement, length. So it has the length. It has also the length. Otherwise we can use the word height. So this is the height of object. This is the height of image. This is also the height of image. We want to measure the size of this image. Otherwise, height of image or height of object. The third sign convention is that the size, if it is measured above the principal axis, taken as positive, it is just like coordinate geometry. In coordinate geometry, from the origin along the x-axis, towards right positive, towards left negative. Then along y-axis, above the x-axis, that is vertically upward, positive, downward it is negative. The same thing we are using. The size measured above the principal axis, positive, and below the principal axis, negative. So this object is placed above the principal axis and the image is formed below the principal axis. This virtual image is formed above the principal axis, then positive. So it must be clear about that all the three sign conventions. First one, all the distances are to be measured from the pole of mirror. Second, if a distance is measured opposite to the direction of light ray, taken as negative, along the direction of light ray, positive. If the size is measured above the principal axis, positive, and below the principal axis, it is negative. These sign conventions are very, very important in solving the numericals in this spherical mirror by using a formula. That formula, which is going to be used to relate the object distance u, image distance v, and its focal length. Relate all the three terms. That formula is known as mirror formula. It is mirror formula. In the next session, we will discuss about that mirror formula.